Okay, let me quickly share presentation. I think it's day 5. Good evening, all. It's week to day 5. So the last theory session in the second week. So today we will discuss about the last category of machine learning, reinforcement learning. So as I discussed earlier, if data is available, labeling is possible, then supervisor is the best one. And data is available, labeling is not possible, then unsupervised. But in some cases, the environment is unknown or statistical model is not available, or the prior data is not available until unless we interact with the real-time environment. So I already explained, right? Having prior data is completely different from getting data from the environment. Having prior data means before deploying our model into real-time environment. Means, for example, if you are training a model for traffic light signals, before placing your model into real-time traffic light system, we should have some data of what is the traffic and what is the different metrics of the traffic, all the things. Then we call it as prior data. But we can get the same data even after deploying our model into the real-time environment, means real-time traffic signal system. That we call it as we are getting data runtime, or on runtime, means we are getting data from real-time environment, but it's not, we can't say that as the prior data set. You get my point, right? So here also we same thing. First we have to again keep one thing in mind, whether it may be supervised, unsupervised, reinforcement learning, or semi-supervised learning. What we generally do is we take one model and we train that model what to do and what not to do. Okay, in supervised and unsupervised, we already have data, and depending on data we can directly check and train the model using the existing data. Okay, this is the good scenario depending on this label, and this is the bad scenario. So in this scenario you have to act like this, and in this scenario you have to act like this, because we have data and label. But here we don't have any data, right? So what we have to do, we have to take one agent like this, and we have to directly interact with the environment. Okay, so we have to take one action. Depending on that action we will get one reward and state, like this, state and reward. So depending on the reward value, what we have to do, we have to train this agent what to do and what not to do. When we have to train what to do, when we get some positive experience or positive reward from this environment when we are doing some action. At the same time, we have to train the model what not to do when we are getting some bad reward. Okay, or sometimes we call it as punishment from the environment to the agent. Okay, so here what we have to do, the from process side, first we have to observe the environment, deciding how to act using some strategy. Means first we have to observe this environment. After deployment, first we have to deploy this model in the environment. After deployment, the model should observe this environment and try to interact with it by taking some action. So here we have different algorithms. All these algorithms are try to optimize these actions, how smartly we can take action so that we will get better reward in short time periods. Okay, we can't perform all the actions, or we can say we can't explore the entire solution space. Only thing here we have to concentrate is we have to cover all the solution space within short time. For example, if you want to understand how the Hyderabad is, okay, we can go to home by home or door by door, and we can understand all the how the Hyderabad is. But it will take huge amount of time, right? So instead of taking, or instead of going through that process, we can go to other process. Like instead of checking all the houses of one colony, we can take one house and we can check, okay, this is the nature of this colony. Like that, instead of going each and everything, we can take some sampling process. Again, while taking the sample, we have to consider the some optimal technique or strategy. For example, in one colony, for example, out of 20 houses, 19 houses are some 2 floors or 3 floor buildings, and one house is the single floor. Let's say it's a old building. So in that case, if what we have to consider, we have to consider one of the 19 houses. If I consider the one house which has one old, which is the old and has one single floor, in that case, that building won't represent entire colony, right? So like that, while sampling also, we have to take some strategy. The strategy is here we derive the strategy using some algorithm. So we will discuss all those algorithms. Once we have the action, or once we identify the action, we can directly perform that action, and accordingly we will get some reward. So receive a reward or penalty from this side, from environment to agent. Once we have the uh, reward or penalty, we can take the learning from the experiences and refining our strategy. So again, day before yesterday, I explained, right? So how we can refine our strategy means, now we have one action. After this action, we are taking left. Okay, when we are taking left, if you are facing some, if you are getting some bad reward, means we are not supposed to be take left. So in that case, what we have to do, we have to take right. So it's almost similar to our supervised learning, right? But in supervised learning, we have data, but here we have environment. So we have to take the action, and depending on the action, we will get some reward from the environment. Okay, so same thing, learning is same, but here we have to select one action and we have to perform that. That is the difference. In supervised learning, without taking any action or without performing anything, we have some historical data, and we are taking the data and we are directly training model. So learning process is same, but getting data is different here. Again, we have to repeat this process so many times or so many iterations to optimize our agent. Any doubt here? The process is same, the learning process is same in all the methodologies. Only difference is here we don't have data, so we have to go into environment and we have to take one action, and depending on action we will get some reward. So again, here action is input to model and reward is output to model. See, let's consider one example how we are doing. Okay, let's say this is our environment. So let's say this is a board. Okay, here you can see one board, right? So at each and every cell, okay, let's say this is one cell. So at this cell we have to take one direction. For example, when your player is here, we have to move the player like this. Okay, when player is here, we have to move the player like this. So when the particular player is at one position, depending on all the remaining, see here it is a wall, here it is a wall. So depending on all these scenarios and depending on different dangers here, how to move the player is the context here. So for that, what we have to do, initially we don't know anything, right? So first we have to take different scenarios and we have to move our player through different directions, and at the end we have to identify whether the player reached to safe zone or danger zone. So if the player, for example, you are here and you are moving your player like this, so at the end if your player reached the danger zone, then we can take, okay, when we are here and we are moving in this direction and the player reached to danger zone, so that is a bad strategy. We have to revert our strategy. For example, when we are here and you are taking this direction and your player reached to a destination, then we can say, okay, this is the one of the good strategy. So at each and every cell we have to identify such strategies. Okay, for the to implement this one in real time, we have to take one table like this. We call this as a state value table, state action table or Q table. We simply call this as a Q table. As this is a Q table, the algorithm is known as Q learning algorithm, and this is the algorithm. First we have to start with one state. Instead of going to this algorithm, we can take this, simply try to understand, let's try to understand this, what we can say, flow chart. So initially we have to start and we have to identify what is the current state. Means initially we have, for example, we are here. So when we are here, what is the different states? up each and every cell. Where is the hazard? Where is the destination? Where is the wall? Everything we have to set all the things here, and what is the position of the player and what is the direction. All the things we have to place here. Okay. Again, when we're taking, sorry, along with this state, we have to identify the actions. For example, you are here, so you can go in this way, this way, this way, but we can't cross the wall, right? For example, you are here it is wall, here it is wall. So you can go up, you can go down. So if in this particular state and for this cell, you have two options to go up and down. So two actions are there. So we have to note down all the actions here. We have to identify. Means, for example, in this example, for any cell, we can go up, down, left, sorry, upright, sorry, up and down, left and right, right? So four possible directions. So in each and every cell, we have four actions. So we can take action one is up, action two is down, left, right, like that. We have to identify all the four actions. We have to create that table here. Okay. And after that, we have to identify all the states here, and each and every state we have to perform one action. Depending on the action, we will get some reward or punishment, right? That we have to place here. Okay. When we are in state one, when we are performing action one, then we will get some reward that we have to update here. Okay, like that. See here, first we have to identify current state where we are currently, and after that we have to take one action. From here we have four actions, right? Out of four actions, we have to identify one action and we have to perform that. Depending on the action, we will go to another state. For example, here we are here, when we are taking up, we will reach to this point, right? So like that, we have to observe what is the next state until we reach the destination. For example, here it is the destination. When we are here, and if you reach the if you take down, we will reach to destination. So like that, we have to repeat this process until we reach the goal. So at each and every state, we have to take one action. We will reach to next state, and we have to check whether we reach the goal or not. And we have to repeat this process continuously. Okay, during this repetitions, we will get one reward, right, at each and every step. So we have to identify that reward, and we have to update in the Q table. So here we have Q table, right? So we have to update. To update the equation, we have one equation here. So this is the old value. Okay, here we have 0, right? So here it is 0. So what will be the new value here? So we have to identify what is the old value, and here we have different factors, like what is the learning rate, what is the discount factor. Possibly, if we have time tomorrow, we will discuss all these factors. So we have to set all these hyperparameters. So depending on all these values, we will get some value, and we have to identify what is the maximum value out of all those four actions. For example, here we have left, right, up, down, right. We have to take all the four actions, and we have to identify what is the better or maximum value in this particular state. Depending on the maximum value, we have to update this value 0 to some 0 0.1, 0 0.2, 0 0.3, like that. So we have to repeat this process again and again. At the end of the day, we will get optimized Q table. This optimized Q table is nothing but the knowledge base. Okay, so we are just learning this table depending on different scenarios. Any doubt here? So this is Q learning, right? So this is the one of the algorithm. Like this, we have different algorithms. Like when we are talking about reinforcement learning algorithms, we can broadly classify into two categories, like model-free reinforcement and model-based reinforcement. What is model-free reinforcement? Is like when we're before going to next step, if we have a estimate of the future reward, okay, then we call it as a model based. If you don't have any estimation of the future reward, then we call it as then we call the algorithm as model free reinforcement learning algorithm. Okay, in model free, we have Q learning and apology optimization as major categories, and model based, we have learned the model and given the model. Means in model based means uh, I already explained, right? Before going to next step, we should have to estimate the future reward. Means before training, before placing or deploying a real-time model, we have to train our model with some simulated data, and then we can directly place that model in the real-time environment. So it has some a kind of knowledge. Using that knowledge, it can understand, okay, what will be the next reward. So that's why here you can see given the model and learn the model. Okay, but in model free means we don't have any existing knowledge. We can directly place our raw model or a reset model into the environment. So here we have two methodologies, Q-learning and policy optimization. So see here, policy optimization and Q-learning. Here policy optimization algorithms try to optimize the policy in order to get the maximum reward. Here Q-learning, here instead of optimizing the policy, these algorithms try to optimize the value in order to get the maximum reward. So here we have different algorithms. Don't worry about all these algorithms. I just want to let you people know so many algorithms are there, but we can't explore each and every algorithm because it will take 3 to 6 months to understand all these algorithms. But just try to understand different algorithms are there. Here you can see policy gradient, advanced actor critic, proximal policy optimization algorithms are there in policy optimization techniques. And in Q-learning category, we have Q-learning, deep Q-learning, soft Q-learning. We have different algorithms. Again, we have some hybrid algorithms. You can see here, it has the nature of both policy optimization and Q-learning. So we have deep deterministic policy gradient and soft actor critic algorithm. These are the some advanced algorithms, and these algorithms can provide some high accuracies. But again, the problem is the complexity is very high for these algorithms. Any doubt here? I think you will have more doubts, but just try to understand there are so many algorithms. Okay, we will try to concentrate on at least one or two while you are performing our lab session. Okay, Q-learning is the one of the standard algorithm. It is proposed during 1988 or 1995. I don't know exact the year, but that is the time frame when it was developed. But still, it is one of the standard algorithm. It's around 30 years now, but still it is the one of the standard algorithm. That is the standard of this particular algorithm. But we have some advanced algorithms to improve the efficiency of the sample. Okay, I explained, right? When we are taking sample, instead of taking entire solution space, we can take one sample and we can identify what is the, I previously explained, right? Instead of taking each and every door of one colony, we can take one house and we can represent that entire colony with that house. So like that, how to select that particular house is the concept here. So for that, few advanced algorithms like soft Q-learning or soft actor critic, these are the few standard algorithms, right? Advanced algorithms. These algorithms use maximum entropy framework. Means before selecting one sample, we have to identify what is the entropy of that particular sample. The entropy is high means we have maximum information in that sample. So we can reduce the number of samples using this framework, but the complexity of the algorithm is too high. So here, these are the few examples how we play maze game using Q-learning. Okay, like this, we have to start our model here, and we have to continuously repeat the process until we reach until the agent or until the player reach the goal state. Okay, we have to repeat this process again and again. At the end of each and every game, we will get one reward value. So depending on that reward, we have to rate each and every step that we have performed during this process. Clear? Coming to libraries, we discussed already so many libraries for machine learning, like SML and UML, like supervised machine learning and unsupervised machine learning, right? What are the different algorithms? Okay. What are the different algorithms? Sorry, different libraries. TensorFlow, Keras, sklearn. Yesterday we used it, right? From sklearn import, from sklearn.tree import decision tree, or from sklearn.svc import svc. Like that, we instead of developing our own algorithms, we can import one existing algorithm and we can train that algorithm using our data. Then we will get the model trained on our existing data. So instead of developing our own algorithms, we can use existing ones, right? So in the same way, we have so many algorithms, so we can import some libraries. See, we have PyQ learning, Keras RL, TensorForce, RL Coach, TF Agent, MemRL, Mushroom RL. We have different libraries. So here we can see what is the different algorithms available in each and every library. For example, if you import this Mushroom RL, you can perform Q learning, SARSA, deep Q learning, DDPG, SAC, TD3, temporal difference 3, and the PO and PPO, proximal pulse. Okay, we can perform different algorithms here. Okay, like that we can use any of these libraries, and we have to train our model. But what is the difference between SML algorithm, means supervised machine learning algorithm, and reinforcement algorithm is, for example, if you are training a model for supervised machine learning, here we have data, we have label data, and we have model, right? So we don't need anything. We can directly take your model, or you can directly take your algorithm. You can apply that algorithm on the existing data and you can train. But in case of reinforcement learning, we don't have data, right? So here we have to create data. Data means we have to create the environment. We see in the previous slides how we are doing here. In previous case, we have agent and we have data, so we can directly dump this data on the agent to train the model, or you can directly use your algorithm on the data, right? But here we have to simulate so many things. Instead of simulating, or instead of creating the simple algorithm, we have to create different parts here. Here we have to create the environment. Here environment means what is the nature of environment. For example, if you are doing for this one, if this is your environment, you have to create what is the size of this board, and what are the different block cells, what is the destination, what is the source, or what is the starting point, and what is the cost of each and every cell. We have to identify, for example, if there are any block cells, we have to identify all the things. For example, here you can see different parts, right? Here you can see all these are the walls, and these are the hazards, and this is the destination, this is the starting point. We have different parts here. Okay, we have to simulate all these things. Okay, for this, to simulate that part, we can use NumPy library, and we can take a matrix. Otherwise, we have to use some existing libraries like Pygame. Okay, Pygame is the one of the existing library. We can directly import a environment like this, and we can directly train the environment. Okay, so to import all those things, we can use these libraries. Okay, this is all about from presentation side. Let me quickly go to the spider. Okay, sorry, still it is running. I have started training of one model, you can see here. So yeah, this is the Pygame. Just now I explained, right? If I want to simulate one environment, we have to import some library in order to make our things easier. For example, if you see here, we can create our player, we can create our agent, we can create our board. But what we have to do to create all these things, first we have to import our Pygame. So here from Pygame, we can easily start, or we can easily simulate all these things here. You can see here. So still it is training the model. So this is the starting point. Here we have to reach this point. To reach this point, we have different parts here. Different cells are here, right? So this is the one way. Let me quickly stop this one. So I have stopped this one. So in this example, if you see here we are not doing anything. We are just, for all these things we have scripts. But here what we are doing here, we are directly taking the Pygame, and using Pygame we are initializing it, and we are running the events. Means, for example, if you are training a model for a chess game, here we have different events, right? We have to move the player, whatever maybe, it may be chess game, it may be simple maze game. We have to move the player from one point to another point We have to write our own logic, or we have to use this Pygame. So here I'm using Pygame, and here I am using all the events. Events means if I want to move from one point to another point. Here, to understand all these things, we required knowledge of X network, or knowledge of nodes and vectors, or we can easily say edges. Okay, here you can see, here we have k comma v. When we have this qlearn, this is the again the player object, but when we are playing, okay, let me quickly open the presentation again. Let me explain. Okay, for example, if you are designing any model for optimization of path, or to play any game, here we have different nodes. So here you can say this is one node, if you consider this is one node, and if you consider this is one node, if you consider this is one node. So here, like this, we have different nodes. Okay, we call all these things as nodes. Along with these nodes, we have these sites as well. For example, if you see here, okay, if we want to move from this point to this point, we have like this, we have one edge, right? So like in the same manner, we can take different edges. Okay, again, we can have multiple paths as well. So in that case, our network will be like this. Means we, for example, if we are here, we can reach this point from this way. Means we can travel to this way, this path, and this path, and reach this point. In the same way, we can travel through this point, this path, and reach this point. Again, we can travel to this path and reach this point. Again, we can reach this endpoint. So like that, depending on the path cost of this, means depending on the distance between from this point to this point, and this point to this point, this point to this point, and this point to this point, we have to identify which is the best possible path, or which is the shortest path. Okay, for example, we have this path also. In this case, we have to identify all the possible path costs here. Means, for example, if you are traveling from this, for example, let's say it's a 2, it's a 3, it's a 5, it's a 1, it's a 2, like that. In that case, we can directly add the values. Or if it is 2 and here it is 2, 2 plus 2. Okay, when we are following this particular path to reach from this point to this point, it will take 4 meters of, or 4 units of distance, or 4 units of time. Okay, in the same way, we can go through in this path, and we can follow this path, like that. Depending on the path cost, we have to explore all the things, and we have to identify. So if we want to implement this kind of scenarios in Python, we have to use X network library. I think it's network X, it's not X network X library. So in network X library, we have axes and edges. So here you can see different edges, right? This is one edge, this is one edge. So we have sides as well as the nodes. Okay, to represent all these things, we use this kind of, see here. Here we have to mention all the points here. What are the different nodes and vertices values? Okay, if you want to implement by your own, you can take like this. For example, let me quickly go here. Okay. Okay, here we have something like this, right, in our presentation. So here we have like this. So here it is 0, 0, 0, 1. Like this, we have it's a 2 by 2, sorry, 2-dimensional table, right? So in this 2-dimensional table, using 2-dimensional matrix, we can represent the same thing. So to represent this entire environment, we can use this kind of matrix. See here, some -1, 0. So we have to represent each and everything using values inside this kind of matrix. So if you want to train your model, you can directly run this one, and we will get like this. Okay, this is the optimized model. and to travel from this point to this point, this is the selected path. So here you have to set all the things. Where is the initial state and what is the final state? All the things we have to set here. Anyway, don't worry about this one. We will discuss this program as well in tomorrow practice session. Okay. Okay, just forget about all the programs for now. Try to concentrate on this presentation, and you can ask any questions in last sessions of last 3-4 days. Okay, in this week we discussed first, we discussed what we discussed. In day one, we discussed different applications, means what is AI, what is ML, and what is DL. Do you people have any doubt between these three terminologies? What is artificial intelligence, what is machine learning, and what is deep learning? Any doubt here? When we call, for example, if you are implementing any application, whether we have to call it as an application of artificial intelligence or machine learning or deep learning, how we are deciding? Depending on the level of the implementation, whether we are handling from scratch, from starting to ending, means including the sensors and responses. For example, if you are taking a robot for some hotel purpose, okay, we are developing a robot as a what we can say servant. Okay, in that case, we have to set our implementation level to some particular level. Means, for example, whether we are implementing entire part using AML, sorry, using this technology or these techniques, like we are optimizing the sensors, means we are using some cameras to identify what is there in front of you, right? So whether you are taking all those things into account, or all the things are already there, whether we want to optimize the path of the robot. Okay, in that case, we have input, output, everything. Motors are there, controls are there, what we can say, cameras are there, everything is there. Just we have to optimize the path. So in that case, we can use machine learning. Okay, again, everything, for example, inside that also, a feature selection is not possible, and just we just have some data, and depending on data, we have to reroute the path. So in that case, we can use deep learning. So like that, depending on the level of application or level of implementation, we can define, okay, this is the application of AI, this is the application of ML, or this is a deep learning application. So we discussed this on Monday, and on Tuesday, we discussed the classification. Classification is nothing but different applications we discussed. And again, on day 3, we discussed supervised machine learning. So now try to concentrate on these algorithms. Do you have any doubt here? In linear regression or logistic regression, SVM support vector missions, Navy base, and decision trees, KNN, or neural network? Just try to ignore this one here, because we will discuss the neural networks in detail in the upcoming week. But if you have any doubt here, you can ask me now itself. Okay, now this week, this is the concept. So now we have around 20 minutes of time. This is all about for Q&A. Yesterday, you guys asked me one question, right? Just before closing the session, why you have to take 80% as training data and 20% as test data, right? So in real time, we have to take as much as data we have for the training. Okay, means if we have more amount of data, we can train our model more efficiently. Means we can get more accuracy. The data is very less, we can't train our model. So we require huge amount of data. In real time, we have to train our samples using few thousands or few lakhs of data samples. Okay, so we require more amount of data, but at the same time, we have to concentrate on validation as well. That's why we are taking very few samples from the existing data, and we are keeping aside for the validation. So in general, we have to take at least 20 to 30% of data. Means at least 20, at max 30, not more than that. If you are using more samples for validation, you are losing your own data. So first major step is training, right? So we are missing some samples for training. It's more or less similar to how much time you are spending for your semester and how much time you are spending for your exams. Is it okay spending entire semester for exam and 1 day for training? Sorry, 1 day for classes? Is it fine for you guys? For example, if you have 6 months, okay, 16 to 30, 180 days. So instead of in 180 days, is it okay for you if I take one class on day one and uh, using the remaining 179 days for examinations? It's not good, right? First, we have to concentrate on classes. So we have to take more days for classes. Like out of 180, we have to take around 150, more than 150 days for classes, and we have to validate how the students are getting knowledge using tests in some 30 to 20 days, right? You people get my point here? Our major goal is training, not validation. But if you want to test the training, how are validate, if you want to validate the model, we have to go for validation. Okay, training is our major purpose, our major goal, and testing is the secondary goal. Any other doubts? If you don't want to unmute yourself, you can write here in chat window as well.
Yes, sir. So here we use 80% for testing, sorry, training and 20% for testing, right, sir?
Yeah.
So when we implement for real-time projects, then when we give some new example like a new object or a new data, then it will validate as per the given data, or it takes like another like.
See here, I think you are talking about lifelong learning models or transfer learning. So we have different methodologies. Means, for example, now we have, let's say, two different data sets. Now we have one is the biomedical data set to detect whether the particular scan of the X-ray has some tumor or not. Means when we are giving the image of one scan, it may be MRI or whatever may be the scan. Okay, the algorithm should able to whether that should able to detect whether the particular scan has tumor or not. Okay, that is one example. Okay, let's take another example. Here we have very simple data, high risk data, and we have to uh, identify what is the particular flavor is or particular species is. Okay, whether it is Setosa or Vaginica or versicolor. Okay, you are training one model here and you are training another model for biomedical or medical application, right? Okay, in this case, let's say now you are training one model for the this iris application. You are not supposed to be use that model to continue its training in the another application like medical application. Means if you want to train two models, you have to take two press models and you have to use one algorithm and you have to train your model for each and every application separately. You get my point? Okay, now you are training here for iris data. Okay, so here we have only 150 samples. Out of 150 samples, you can take 120 samples for training and 30 samples for validation, right? So here it is completely different. For example, now you have biomedical data. You have, for example, 1 lakh scan reports. Okay, out of 1 lakh, you can use 75 lakhs of data for training and 25 lakhs of scans for validation. So this is completely different application. I didn't get your point whether you are saying, okay, I have trained my first model for iris data. Okay, here my split ratio is 80:20. Now I am using the same model in the another application like medical application. So here what I have to set, right? That's what you are asking, or anything else?
No, sir. No, sir. I'm not changing the domain. I'm with the same data set. If
Okay.
the given new element is somewhat different but similar, then what is the rate of prediction? Like it will be predicted, or we have to give a new data set for that element. Like we have taken last week Saturday, we have taken three types of plant flower types, no, right, sir?
Yeah, iris data.
For that, we are getting some similar on the flower. So it will range in that ratio, or it will give an error like that. I'm asking.
Okay. Now,
Like we are testing
yeah,
for we are
yeah, yeah,
testing
yeah,
data
yeah. Now I
for our
understand.
convenience that what's the ratio. But when we are giving the live or
Yeah, yeah,
data,
yeah. Now I understand. Now I understand your problem. Now let me explain. Okay. My first question. What is my first question on day one? This is my first presentation, right? Okay. What is my first question? Are machines intelligent enough? This is my first question, right?
yes, sir.
Okay. Now keep this question aside. Back to this slide. Okay. Now what will happen in real time? Let me explain clearly. Okay, we have 15 more minutes, right? It's more than enough. Okay, here I have one model. Let's say it's my train model. Okay, it has two categories, only two categories. I am training this model with initially in real time, it has only one input. Sorry, why I'm taking all these things. Okay, it has one input, like one image. Let's say one image. We have to provide one image here. Okay, depending on the image, it will provide the name of the class. Any doubt in this example?
No, sir.
Okay, now let's try to concentrate on data. So here I have my data set. This is training phase. Okay, inside my data set, I have a cat image and a cat image and a cat image like this. So many images and a dog image. Okay, and a dog image like this. Okay, this is my data. Now I am training this data, and here I have to set few things. Okay, here I have two classes, right? In that case, my output will have two classes like this. This is one class and this is the another class. Okay, when I'm giving the first cat image here, instead of image, I am giving the cat image here. Okay, when I'm giving the cat image, what will appear here? Do you have any idea?
It will differentiate whether it's cat or dog.
Right, that's what we are thinking, but in real time what will happen, right? Here it will provide a value like this. For example, here it may be 0.6 and it may be some 0.3, and we are calling this as sorry, where is it? Let's say in white color. Let's set it to some tall. Okay, here we are calling this as cat class. Okay, and here we are calling this as dog. Okay, so now we have two output variables whose value is the cat value 0.6 and dog value 0.3. Okay, here we are when we provide cat, then this will be the scenario, or it may be some 0.1 as well, depending on the image. Any values may be, or it may be 0.4. Okay, when we are giving this cat image here, then the model output is like this. It's not cat, it's not dog. We have both the classes and we have values like this. Okay, then in that case we have a logic to identify what is the maximum value out of these two. What is the maximum value? What is the
First
maximum
one,
value?
yes.
Cat, right?
Yeah.
So then we will define, okay, here this variable has the highest value, so this is a cat. Okay, any doubt here? This is what will happen in real time. For example, now you are saying, okay, now my training is done. So in real time, when I am handling this one, what you are saying?
So let me continue here. Like here we have taken two sets like cat
Yeah,
and
yeah,
dog.
yeah, yeah. That's what I am explaining. Instead of
Or
taking
in
dog, I am
each,
taking a cow.
uh,
This is the one, right? You are talking about. This is
so
your
like
doubt, right?
similar characters. If we take like here cheetah or a tiger, it looks similar to cat, right? So now what happens? Like
Yeah, yeah, yeah. That's what I am explaining. Okay, here you have taken a tiger. Okay, even you provide tiger here, what will happen? Here we have only two classes and there will be some probability for each and every class. Here it may be 0.5 and it may be 0.2. Okay, because we have only two variables, one variable per cat class and another variable per dog class. Clear? You have trained this model only to identify two classes. Okay, whatever may be the input, it will provide two values to these two variables, and depending on the values out of these two, you have to identify what is the maximum one, and that will be the output. Clear? Any doubt here? Here you may provide tiger, or you may provide lion, or you may provide a rat, or you may provide a flower instead of an animal, or you can provide your face as well. But the model doesn't understand all those things. It just know how to classify that image into these two things. Okay, depending on these two values. Now understand my point, right?
yes.
So here you are providing an image and model don't know what is that. It can't understand as well. But depending on different pixel values, it will produce one value here and one value here. Okay, as we have two categories out of these two, for example, depending on features, here it may be 0.3, here it may be 0.2, nothing is 0.5 more than 0.5, right? But still 0.3 is higher than 0.2, right? So you can identify, okay, this is the animal which is a cat, whether you provide a flower here. You get my point, right? That's why I mentioned in the first class. I know this point. That's why I mentioned in the first class, machines are intelligent. You know, to understand data or situation, machines are not intelligent. You have to understand the data or situation. Okay, we have to set all these things. Okay, we have to set the labels and we have to provide the data. Okay, we have to set a label of dog. Okay, and we have to say the model, okay, this is a dog image, try to understand it. Okay, once we perform these things, then machines are able to take decisions, control process, perform operations intelligently. Okay, but you are misleading your system here. You are intentionally misleading, right? You train this model only for two categories, a cat and a dog, right? Okay, so you have to use this model where only two categories are there. If you want to train your model for tigers as well, what you have to do? You can use transfer learning, or you can use continuous learning, or you can retrain your model by adding few tiger images here. Now we have two cases, right? So you can add some tiger images in the data set, and you can add one more class here. Okay.
Yes, sir.
So like this, you can add one more class, and you can use this model. That is the exact way of doing things in real time. That's why in the first step, what is the first step? First, we have to understand your application. Okay, what you are doing using this model, why you are going for a training of machine learning, and what is the purpose of that learning algorithm or model. Whether you are replacing in traffic signal application, or whether you are replacing identification of person. Okay, for example, you have trained a model to identify speaker. For example, let's say simple application, speaker recognition system. Okay, you can take voices of some different 10 persons, and you can ask who is the person. Okay, it will provide one name, right? But when you are introducing some 11th person, and if you ask the model who is this person, it can't identify, right? Even it tries to identify, it can classify into one of these 10, right? Because he knows that particular model knows only 10 persons, but you are introducing 11th person without intimating the model or without intimating the system. Means you are intentionally misleading the system. You are trying to misleading the system. Systems are not intelligent enough to identify all those things. Still, we have ways to do that, but we have to use some advanced techniques like transfer learning, continuous learning. We have different techniques. Okay, for example, here you have some 0.3 and 0.2, right? Here you can have a threshold value of some here you can have a threshold value of 0.5. Okay, means here you have set a threshold of 0.5, and you are instructing your system. You are intentionally instructing your system. If both the here I have only three classes, right? If all the three classes, the instruction will be like this: try to identify the maximum one. If the maximum value is less than 5, try to add a new class. Okay, for example, in that case, for example, here you provided a image of a let's say another some monkey. Okay, in that case, if for example all the values are like this, here it is 0.3, 0.2, 0.2, right? Okay, let's say first you have a cat. So in that case, the cat value will be some 0.7. Okay, what is the maximum one? 0.7, and it is greater than 0.5. So it will assess this particular image as a cat. Okay, then your output will be cat. Clear? Now you are introducing a monkey image here. When you are placing a monkey image at the input of this one, okay, then in that case, let's say here the probability is some 0.3. What is the maximum value here? 0.3, 0.2, 0.2. 0.3 is the maximum value, right? Then it will compare with the threshold value. Here it is 0.5, less than 0.3 is less than 0.5, right? So then it will detect, okay, the input image is none of the above. So in this case, it will ask the user, please provide the category name. I will try to learn it. Okay, in that case, it will we have to provide, okay, this is a monkey. Then the model add one more class here. The model itself can add one more class here, and it will try to save this species as monkey here. Clear?
Sir, what if all the values are equal?
No problem. No. In most of the cases, we instead of taking the one decimal here, we can take up to few decimals. Okay, like this we have few many values, so there is no possibility to get all the classes as equal. If all the classes are equal, what will happen in Python? Again, if you have such doubts, you can go to your what basics of Python. Okay, if you want to if you try to find the index of a, okay, let's go back to your Python terminal, and here let's take a some x is equal to 1 comma 2 comma 3 comma 4 comma 2. Okay, x dot index of 2. What is the value here? Are you people able to see my screen?
Yes, sir.
Okay, if you are providing index of 4, if you're asking what is the index of 4, it will give you 3 because 0 1 2 3. So this is the position. Okay, but here I'm asking what is the index of 2, then what will happen? The first value will get the will be available at the output side, right? Okay, same thing here. We are trying to identify the maximum value, and if the maximum is, if all the values are same, the first value will be taken as the output. That is from program side. But when we are talking from the other side, what is the other side? Machine learning side, there the probability is very less. It may almost 0, because here we are not taking 1 point, 1 decimal point. We can take up to what we can say, up to 10 or 15 decimal points, depending on the application. Any doubt here? If you use like this, okay, there may, if you consider only first decimal point, here it may be 0 0.2, 0 0.2, 0 0.2. But if you consider n decimal points like this, there is some difference, right?
Yes, sir.
Yeah. Any more doubts? Here you get my point, right? For example, how many of you people using Alexa or Google or Bixby, Samsung's? How many of people are using?
Probably everyone's are these days.
Okay. So try to ask few questions. Ask a simple question. Hey Alexa, or okay Google, what is my name? It will answer your question. Then ask another simple question. Okay, okay Google, what is my favorite food? Then what will be the reply? Probable reply. It will reply simply like, I don't know that part. If you tell me, I will remember. Any one of you tried that part? It will clearly reply like that. And it will try to, yeah, it will try to listen as well. Once you provide the data, it will understand that and it will store in its database. Okay, this process is known as incremental learning or continuous learning. Previously I mentioned, right? Here in this session or in this course, I am trying to explain the basic algorithms, but so many advanced techniques are there. Already developed ones are there. Okay, once you understand the basic ones, we can go for the latest ones or the advanced techniques. Any doubt here?
Yeah, sir. The model which you are writing algorithm, right? How that algorithm internally works? Like we have some Navi-based methods like that.
Yeah, that's we discussed already discussed, right? What this algorithm will try to do in each and every. I think, are you there in yesterday's class? Yes or no?
No, sir.
Yeah, that's why you are asking. You are you people are missing the classes and you are asking again and again. In day before, I think not in the yesterday's class. It in the day before yesterday, I think, right? Anyone was there in the day before yesterday's class? Can anyone explain how this will work? This linear regression? I have taken a equation y is equal to mx plus c, and I explained, okay, here we have to the work of the algorithm is to identify the slope and the bias of this particular line in order to match or in order to fit all these points like this. Okay, initially we don't know what is the exact what we can say. Okay, let me go to the presentation mode. I have explained all these things. but you people are missing classes and you people are again asking again and again. So you can see here, right? Here we have 2 points. Sorry, so many points here, right? So here we have to the task of or the main goal of algorithm is to identify this line when we are talking about linear regression. Okay, here we have some points. You can see some stars here, right? We have some points, and we don't know. As a human being, you can easily, if I provide some dots here like this, okay, if I ask you people to draw a line which can match or it can fit all the points, you can directly draw like this. But how can a model can understand all those points? Don't have intelligence, right? It doesn't have any intelligence. So in that case, what will happen? Even the points are like this. Okay, first initially it will take a line like this. Okay, now it will try to understand what is the distance from each and every point, and this is the error. Okay, it will calculate all these points. Now it will try to move the line like this, rotate the line like this. Now we have another line, right? So using this line, now again it will try to calculate the distances from all the points. Okay, now what will happen? For example, initially the error is 100, now it is increased to 120. Now the model can able to understand, okay, I am moving in the opposite direction. I have to tune the line or tune the model in opposite direction. Now what will happen? It will go back in this direction. You can see the direction here, right? So it will go back in this direction and it will draw a line like this. Now what will happen? If you consider the perpendicular distances like this, now the value will reduce to some 80. Okay, now can the system can understand or the algorithm can understand, okay, I am going in the right direction. So now what will happen? Let me change the color. Now what will happen? It will move again in this direction and like this direction. Okay, at this point, this is the optimal direction, right? Okay, after this also it will try to move the model like this, but the cost will increase reduce 70 50 like that, and again it will start increasing from this point to this point. Okay, now the model again understand, okay, I have crossed the optimal point, I have to go back and tune here. So again it will try to tune here, and finally you will get this line. Okay, here we are performing some tuning process, right? By moving in this direction like this and in this direction like this. Okay, this moving or this tuning process will be taken care by the algorithm. Okay, at the end of the day, you have a straight line here, right? Okay, so for this straight line, you have y is equal to mx plus c equation, and that value of this m and c are there, right? So this is the base value and this is the slope value. These two are known as the knowledge. Okay, now at the end of the day, if you have a point here, what is the value of this part? Okay, you can directly take that line here, and okay, this point is crossing here, so you can take the corresponding value here. Okay, this will be the regression value for this particular point. Okay, this is the future, or we can call this as a inference, and here we are going for training. You get my point, right? Any doubt here how we are using all these algorithms? So like this, we have different approaches for each and every algorithm. If you are going for Navy base, we have one method, okay, to calculate what is the final ratio that become what is the final ratio of that point, whether it goes into one class or other class. I explained all these values. I explained decision trees as well, how we are going, how the algorithm is classifying. And I explained KNN as well, how we are taking, how we are reducing, or how we are grouping into different classes. Like this. Okay, first we have to identify the shortest distance and we have to group them. After that, we have to identify next shortest one, after that next shortest one. If so, like this, we have to reach this point. At the end of this point, we will have these two groups here like this. So this is the input and this is the required one. But what is the workup algorithm is to group like this. So I have explained each and everything. I think it's your problem. It's from not from my side. Any more doubts? That's why I'm asking, try to attend the session and try to be interactive. If you have any doubts, you can quickly ask the question. Once I have completed with any algorithm or any model, you can quickly ask there itself. Okay, it will be helpful for both you and me. Okay.
Yes, sir. Thank you.
Okay. Okay, try to bring your laptops if possible. Okay, last time very few laptops are there. If you have laptops, try to bring them and be there by, I think I will be there by 10 and 10:30. So be there by 10 and not don't shift from one room to another room. That was happened in the last time, right? So try to select one room quickly. This is for seers who is leading people. Try to select one room and prepare everything ready. Okay.